Imagine living in a third world country where you lack food, water, sanitation, and electricity. All these four things are essential for someone to survive in an underdeveloped country. Without food, they can't eat. Without water, they can't drink. Without sanitation, they are prone to infection. And without electricity, they can't cook their food, provide warmth, or light at night. The aim for my project, the Discus, is to reduce one of these four different issues so that the quality of the other three can increase. I've chosen electricity. Electricity is a necessity for people in underdeveloped countries and countries all around the world. Many people in these countries don't have access to heat or warmth, or even a light during the night. In some cases, electricity lines aren't even connected in underdeveloped countries. The ongoing power bills for electricity is way too much for people to afford. What I've done is tried to create a product that solves this issue. I call it the Discus. I will try and create a small device that will be able to charge a battery with enough energy to power small appliances, like a stovetop or a lamp. This device must charge easily through an attachment that connects to your bike. Utilizing the power of this bike that people ride to and from work, going about this, I had to do a few different things. I had to do various design methods like sketching, prototyping, 3D modeling. It had to be lightweight, durable, and last long enough that it was a one-off payment. Then we would be able to successfully fill the need for this product. I've gone about this by choosing the right materials. One material that I've chosen to make the disc out of is Norral. It's an industry-grade polymer that is cheap enough to sell and make. It has a melting point that is above 100 degrees, which means that in super hot conditions, the people won't have to worry about the product melting. It's also very durable. It's shock resistant and resists water and is not an electrical conductor, which is awesome for the electronics that would be inside my product. I'm also using generators. These generators are 4-volt generators that power the whole disc that will then power the battery. I have then also had to choose various different ways to create a product that is waterproof so that the electronics inside will not be affected. The method I've used is using an O-ring within the external shell of the product. I've tested this by running water over it with a tissue inside, as there's a video I'll show you in a sec. Throughout testing, I've had to ride the bike myself and have other people ride the bike to see how much power I can get out of it. This table here shows that the amount of power that comes out of it would be able to power a small stovetop for the night. 50,000 milliamp hours is created over a 10k bike ride. 25,000 milliamp hours over a 5k bike ride. The average person over in India riding to and from work on a bicycle will be over 5k's. 20,000 milliamp hours is enough to power the small stovetop for about an hour and also be able to power a light for an entire night. After prototyping my whole project more than 4 times over, I've had to evaluate it each time to get the best result out of all of the prototypes. The evaluation of the prototype has been tested thoroughly. It has had shock resistant tests, waterproofing tests, power tests, and I've therefore created a successful product that I'm hoping that will fill the need. The product, unfortunately, is non-biodegradable. If the product does break, it would have to be returned back to the manufacturer and melted down to create new products of the same material. The plastic, if not recycled properly, is prone to releasing harmful gases. This means that the product must be disposed of properly or returned to the manufacturer so that we can recycle. Throughout all this designing and testing, I hope that me, Ben Thomas, can have created a product that would best suit the people in this area for the needs that they need. I hope into the future this product can be manufactured and put into production so that people in these underdeveloped countries can live a better quality of life.